Greetings, Science Fam. Today we are actually going to be doing the M&M Half-Life Lab. So what we have here is actually 80 M&Ms that are all M face down. What we're going to do is close the box, shake them for 10 seconds, and then count and see how many M&Ms are now face up. The idea here is that if we have them all face down and we shake them randomly, think about what percent of all the M&Ms will now be face up. Well, if you can only be up or down, you probably have a 50-50 shot or so. So we're gonna take that and record that in order to better understand what a half-life is for a radioisotope, an element that naturally breaks down. So the first thing is that you have your data sheet at 0 half-lives with 0 seconds gone by. We have a total starting of 80 M&Ms. Let's now take the M&Ms, shake for 10 seconds, and count how many M&Ms we have that are now face up. So we'll take it and we'll shake it. All right, so that was 10 seconds. Now what we're gonna do is pull out any of the M&Ms that are now face up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, let's see, 36, 37, okay, 37, 38. So right now, 38 flipped over. All right, so how many M&Ms remain face down? Well, what's 80 minus 38 because we lost 38 of them? There's 42. So there's 42 remaining. Is that about half remaining? Yeah, it is. So I wonder why we're calling this half-life in that. Okay, let's close up the box. Let's shake another 10 seconds. All right. Now that we have that for 10 seconds, let's go ahead and count how many have flipped over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, let's see, these are all face down. 15, 16, 17. So about 17 flipped over. So 42 minus 17, that's 42 minus 7 is 35, minus 10 is 25. So it looks like we have about 25 remaining. All right, let's shake for 10 seconds again. Can you estimate about how many will be flipped up this time if we have 25 left? All right, so 10 seconds. So we're starting to see that about every 10 seconds, about half of the M&Ms are gone. We'll see if that's the case. Here's one flipped up, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. About 12. So we have about 13 M&Ms left because we lost 12. All right, let's shake again. 10 seconds. All right, we have 13 left. Let's see how many here have flipped up. 1, 2, 3, 4, 5. About 5. So we should have about 8 left because 5 flipped over. Let's double check. 1, 2, 3, 4, 5, 6, 7, 8. Oh, perfect. We've got 8 left. Let's do it again. 10 seconds. If you have 8 left, we could assume what? About 4 are gonna flip over? Now it's not perfect. But we're getting the idea that around 50% each time is going. Let's see what flipped. 1, 2, 3, 4, 5. So this time, 5 flipped over. I think I flipped that one myself on accident with picking them. So 5 flipped over. There are 3 left now. All right, one more time. Let's see. What do you think? 1, 2, or 3 will be flipped over, or none? It is totally random, right? But let's see. All right, what do we got? 1, 2 flipped over. So we now have one left there. Perfect. And we've gotten our data. We wanted to go to 1. Now that you see this data, we can start thinking about went from 80 to 42 to 25 to 13 to 8 to 3. So what you are going to do is try to graph your data looking at and seeing the amount of M&Ms on your y-axis versus how many half-lives it went through. Remember, each half-life was 10 seconds because we shook it for 10 seconds. So about how many M&Ms did you lose every 10 seconds? Well, think about that, and again, try to better wrap our heads around M&M Half-Life. All right? So now that you've gotten the data, you can move forward with your lab. Best of luck, science family.